Good evening, everybody. Welcome to another session of Physics, Brilliant Education Center, Doha. I myself, Muhammad Shamim, last 10 years as the faculty of Brilliant in Physics, and I'm a research scholar in nanotechnology in NIU University. Okay, we have no time to talk more. We have only 24 days remaining for the board examination now. February 24th it is starting. I know 16th is starting for some EG students. I'm sorry for them. So examination is on 24th starting. So we are having 23 in February and 3 days in the last days of January, total 26 days. So come on, we are doing some important questions in current electricity today. So the questions we selected all are multiple choice questions, and the questions are coming from the previous board examination and also NEET examination, not very last, see 2022, 21 and 20 board questions we are doing, along with some NEET questions possibly coming in our MCQ for board examination. So we can go to the questions now. Come on. So the first question I'm explaining now. The electrical resistance of a conductor. It's a 2020 question where is directly proportional to its area of cross section, decreases with increase in its temperature, decreases with increase in its conductivity, independent of its shape but depends only on its volume. So the right option here, we can say electrical resistance formula that we know correctly, R is equal to rho L by A. So it is not directly proportional to area of cross section. So the first option is definitely wrong. And then we are doing the second question. Decreases with increase in its temperature. Option is very wrong, that we know, because in the case of a conductor, the resistance increases with increase in temperature. So option B is also not correct. Decreases with increase in its conductivity. It's a right option, because we know when conductivity increases, definitely resistivity decreases. So resistance also decreases. So the right answer is correctly that option C, the right answer, decreases with increase in its conductivity. Hi all. Okay, now we are doing the next question now. So that is question 2. We know it is in the question of mobility. Unit is always coming as a very important question for examinations. New quantities when we are studying, we have to study about resistance, resistivity, mobility, conductivity, conductance, drift velocity, current density. All the new terms, their units are a possible area for MCQs. So here the question is given, meter square volt inverse 1 second inverse 1 is the SI unit of which of the following? So here the data is given, that is drift velocity, mobility, resistivity, potential gradient. So we can check first whether it is for drift velocity. Drift velocity is in meter per second. Velocity it is. So its unit will be meter per second. So no chance for drift velocity. Then the next one we are talking about mobility. So what is mobility? Mobility is equal to the drift velocity divided by electric field. Mobility VD by E is there. The unit of VD meter per second. Electric field, what's the unit of electric field? We know electric field is equal to volt per meter. So we can say it is volt per meter is there. This meter will come to the numerator. So we can say it is meter square volt inverse 1, second inverse 1. So the right answer is meter square volt inverse 1 second inverse 1 is that for mobility. So the right answer is for mobility. The unit meter square volt inverse 1 second inverse 1 is there. Now we are trying the next question. So look, what is the question there? The ratio of electric field and the current density at a point is called. So you know, we have to say electric field and current density. We studied in current electricity the relation. What is the relation that we studied? You know, J is equal to sigma E. We have the idea where J is current density, sigma conductivity, E for electric field. So J equal to sigma E is there. So the ratio of current density to the electric field, J by E. J by E will be sigma coming. J by E is sigma. But we need the ratio of electric field and current density. So it is reverse. So we can say correctly that is E by J will be there. E by J is 1 by sigma. 1 by sigma is equal to rho is there. Yes, many are there giving the answers correctly. Yes, Joel, the right answer it is. So we can say that is 1 by sigma is equal to rho is there. So we can say it is for resistivity. So the question for resistivity. Someone is asking, can you explain the second question again? So I will explain that question once more. Please see the second question. So please see once more, I am showing the slide now correctly. So now the second question. Meter square volt inverse 1 second inverse 1 is the SI unit of which of the following? We know mobility. See, the second question I am explaining once more as per your request. Mobility. Mobility is Vd by E, drift velocity by electric field. Drift velocity meter per second and electric field volt per meter. So this meter come to the numerator. So it is coming meter square volt inverse 1 second inverse 1 is there. So the right answer for this option is B, that is mobility. And here now, so we explained question 3. Question 3, the right answer is resistivity. Now we are going to the question now, question 4. That is, we can say question 4, the question 4 is 2020 question correctly, and we can see the question here. A uniform wire of resistance 2R is bent in the form of a circle. The effective resistance between the ends of any diameter of the circle is. So here there is a uniform wire having resistance 2R. So its resistance 2R. It is bending in the form of a circle now. Form of a circle. So if it is bending in the form of a circle, resistance still will be 2R. But they are asking, what is the resistance between any diameter of the circle? Any diameter of the circle. So look, I am marking here a point and here a point. So this is the diameter of the circles. So we can say I am marking point A and point B. Now it is very clear that is this circle will be dividing into two equal half now. So we can say upper part have resistance R. Upper part have resistance R. Lower part also have a resistance R, because the total resistance is 2R. 2R is dividing into R and R. 2R dividing R and R, because their length are equal. So we can say R and R are in parallel now. So when the resistors are in parallel, we can find the equivalent resistance. We have the formula, equivalent resistance formula in parallel, 1 by R plus 1 by R. That is equal to 2 by R. So R equivalent is equal to R by 2 is there. R by 2. So the equivalent resistance is R by 2. So we can say the right option is C. the right option is C coming, that is R by 2 is the picture here correctly, because R and R are connected in parallel, so the equivalent will be R by 2. The right option is coming option C now. Option C. Someone is saying it is D, D is wrong. Actually, the right answer is option C. Option C, the right answer. Okay, now we are moving to the next question. So this question is 2022 question, 2022 CBSE has two examination that and one examination term 1, other one is term 2, and in the term 1 examination we have only MCQs for the part 1 textbook, and for the term 1 examination current electricity we have 3 questions, and out of this is the one question. So practice the real question in the class now. So look, the equivalent resistance between A and B of the network as shown. So we may think that, look, there is an R here, and we can say there is an R here and there is an R here. So all the 3 R are there connected in series. So equivalent may be 3 R ohm. But that is wrong. Why it is wrong? Because there is a connection given. So we can see that correctly. Look, there is a connection given like this here in this manner. So please see, there is a connection. So what is the meaning of equivalent resistance between A and B? It means that you are connecting the battery terminals between A and B. It means the battery positive you are connecting to A and the battery negative you are connecting to B. That is the meaning of equivalent resistance between A and B. So one terminal connected to A, other terminal connected to B. So current will flow. So current flowing from like this. When current reaches here, look, there is a least resistance path is there. Current always selects least resistance path. Don't forget, current, if there is 2 path is there, current always select least resistance path. So we can say the current flowing through this path now currently. And then when current reaches here, it will go through this. So the current flowing through this path is not there. So they are in series now. Look, R and R are connected end to end. So the equivalent resistance R equivalent is equal to R plus R, and that is equal to 2R ohm is the right answer. So we can say the equivalent resistance is equal to 2R is coming. In order to find the equivalent resistance between A and B, we neglected this resistance because no current flowing through that. Current always select least resistance path. Now we are explaining the next question. So that is question 6. The effective resistance, 2021 NEET exam question it is. The effective resistance of parallel connection is given here. So you can see that consists of 4 wires of equal length, equal area of cross section and same material. Each word have their own importance. Look, equal length, equal area, and we can say same material. So we know why these words are coming in the question, because we know resistance equation R equal to, what is the resistance equation? R equal to rho L by A. So look, we can say same material. So I can say rho remains same. Same length. So length is okay. Area is okay. So we can say resistance remains same. So for all the 4 wires, they have equal resistance. So look, 4 wires are connected in parallel now. So if 4 wires are connected in parallel, what is the equivalent resistance? We know we have the shortcut. R equivalent is equal to R by 4. So we can say R equivalent is given here. What is the equivalent resistance? 0.25 ohm is the equivalent resistance. So we can say 0.25 R by 4. So R equal to 4 into 0.25 and that is equal to 1 ohm. So each resistance is 1 ohm. So we can say this wire has resistance 1 ohm, and this wire has resistance 1 ohm, and this wire has resistance 1 ohm, and this resistance also have the resistance 1 ohm. So look, all these 4 wires now we are connecting in series. So we can say 1 ohm, 1 ohm, 1 ohm are connected in series. So what is the equivalent resistance now? R equivalent is equal to series addition only, 1 plus 1 plus 1, and that is equal to 4 ohm. Yes, Suhail, you can ask. Yes, Suhail, you can ask. Some doubt is there, someone is asking, please ask now correctly. Yes, you can come and you can ask. Okay, now see, look, so the equivalent resistance is, I know you are typing, I'm waiting for your doubt. Okay, now look, R equivalent is equal to 4 ohm is there. So the right answer here, option A, the right question is coming. Now look, now we are doing the next one, question 7. So question 7 is actually 2022 CBSE question 7. The last year board question it is, as I told, term 1 exam question. Please see the questions here. First one, this is a case study question. Now there is a difference that, you know, in case study we don't have no MCQs now. We have in case study now this year board we have 3 questions. And these 3 questions have, first 2 question will be theory and the third question will be a numerical. The third question will carry 2 mark, first 2 questions will carry 1 and 1 mark each. So that is the new pattern in the CBSE exam. But last year we have a case study, that is all MCQs are coming, 4 MCQs. So here we can see the question. An experiment was set up with the circuit diagram shown in figure. Assume R1 equal to 10 ohm, R2 and R3 equal to 5 ohm. Small r is 0 ohm correctly. Now see, then E equal to 5 volt. So here the questions are given correctly. Small r is 0 ohm and we can say R1 is 10, R2 and R3 are 5 given. They are asking the points with the same potential are, where the potential is same. We can say first option B, C and D. Look, B, suppose the potential is, suppose I am considering the potential at the point B. If I am considering the potential at the point B is V. Okay. At the point C also it will be V, because there is no drop between B and C. But they are giving D. D potential is not same, because when current flowing through R2 there is a resistor here. So this potential not equal to V. So first option is wrong. So we can say correctly, because B and C have same potential but D does not have the same potential. So we can say correctly this option is wrong. Next one they are giving D, E and F. So that we are checking now. Look, D, suppose I am considering the potential at the point D is V. Look, at the point E also V. Why it is? Because between D and E there is no resistor. So we can say it's same only. But at the point F, the problem, there is a resistance came. So I can say at the point F this is not equal to V. So B is also wrong. Now they are giving F, H, J is there. Look, suppose I am taking the potential at the point F is V. Okay, imagine. Now look, here there is no drop. So here also V. Here also it is V. Here also no resistor. So V is coming. So we can say F and H and J will have same potential. So we can say the right answer is option C, F, H, J will have a same potential. So one point I am saying, in order to find the potential difference, we are checking whether there is any resistance in between that points. So as there is no resistance between the points, we can say here the point F, the point J and the point H have a same resistance. Okay, now the second question we are trying now. Current through the branch BG is, so look, we have to find the current through the branch BG now correctly. So just erasing this all, marking now, so to avoid the confusion for the second explanation. So look, current flowing through the branch BG is, so how we can say correctly? Nitin is asking about that. Sir, what about A, H and I correctly? Look, A, H and I will be not equal, because here this is a question from your side. Yes, Nitin, I will clear your doubts. See, look, here A is there correctly, okay? But you are crossing a cell. As you are crossing a cell, there is a potential drop. So H will be there. And we can say I will be there correctly. So that is, they are not equal now correctly. So we can say now the next point, the current through the branch BG we want to find. So how we can find the current through the branch BG? You can find the total resistance of the circuit now correctly. How we can say, look, R1 is there. And R2 and R3 are in series. So R2 is 5 ohm given, R3 is 5 ohm given. So this branch is 10 ohm. This branch already given in the question, 10 ohm it is. So 10 ohm and 10 ohm are in parallel. So what is the equivalent resistance? Equivalent resistance is, that is 10 ohm and 10 ohm are in parallel, means 10 by 2. So we can say 5 ohm it is correctly. So R equivalent is 5 ohm. Now if we have a R equivalent 5 ohm is there, I can find current. I is equal to E by R equivalent. So what is the EMF given in the question? 5. So 5 divided by 5, that is equal to 1 ampere. So the current is 1 ampere. So when we have the current 1 ampere, how I will calculate the current flowing through the branch BG? So you can see, look, suppose the current flowing from this cell, look, current flows from the positive terminal of the cell. So current flowing like this, the current I. So the current I reaches here. When that current reaches here, it will splits into two parts, because here there is a branch. Here there is another branch. Look, this branch have a resistance 10 ohm. This branch also have a resistance 10 ohm. Since they have equal resistance, splitting will be equal. So the current here will split into through this one. So this is I by 2 will be there. Through this also, the current will be I by 2, because the branch BG and the branch CF has equal resistance. So we can say the current through the branch BG will be equal to half of the total current, I by 2. So we can say the current is 1. So we can say 1 by 2 ampere. So the right answer is option C. That is the right answer for the second question. And then see the third one, the power dissipated in R1 is there. So what is the formula for power dissipated? Power dissipated has the formula, that is V square by R, or we can say I square R is there. So any formula we can use correctly here to calculate the power flowing through, the power dissipated in the resistance R1. So as they are in parallel, I can take a V square by R, because the voltage across R1 will be same as the battery voltage. Battery voltage is given, it is 5. So we can say 5 square divided by R1. R1 is 10. So that is equal to 25 by 10. That is 2.5 watt. So the picture correctly, the power is 2.5 watt. Right answer is option B. option B, the right answer is coming. Now the next one, the potential difference across R3 we want to find. So how we will find the potential difference across R3 now? You know, what is the meaning of potential difference? Potential difference means voltage. So that is IR. So across R3, so current flowing through R3, in the resistance R3 will be there. So what is the current flowing through R3 now? Currently it is I by 2. I by 2 is 1 by 2. So we can say the current flowing is 1 by 2 and R3 resistance is 5 given. So that is equal to 5 by 2. So that is 2.5 volt. So we can say 2.5 volt correctly. So yes, right. Yes, there is a cell. That's why. So 2.5 volt is there. V3 now correctly. So we can say this the picture now. The potential difference across this. So please rewind this picture now. This is the case study question. Last board examination. So we cracked that question, a simple circuit question only. So we have the which points have same potential and what is the current through the branch BG and what is the power, and we can say what is the potential difference across R3 also. Lock in mind, potential difference means voltage V we are calculating. V equal to IR, the current flowing through that. Okay, now we are doing the next question. Now see, look, question 8. It's a direct question but came in 2022 board paper. So 3 questions in current electricity last year board. So the first question, if N, E, tau, M are representing electron density, charge, relaxation time and mass of electron respectively, then the resistance of the wire of length L and cross-sectional area A is given by. Everyone knows this direct one. Yes, as you all said the right answer correctly, you know, ML divided by N E square tau A will be there. So the resistance is here correctly, that is ML divided by N E square tau A. The right option is option A. It's a direct question coming. ML by N E square tau A is there. Now the next question, question 9th. Which of the following have a negative temperature coefficient of resistivity? So look, negative temperature coefficient of resistivity, which of them have? There, this is a very important area for MCQs. Variation of resistance with a temperature. We know in the case of metals, when temperature increases, resistance also increases. So we can say the coefficient of temperature coefficient of resistance alpha will be positive. Alpha will be positive. In the case of insulators and semiconductors, the picture is different. What is the idea for insulators and semiconductors? When temperature increases, its resistance will decrease. So we can say alpha is for insulators and semiconductors, alpha will be negative. Alpha negative. So you know the point correctly. Look, alpha negative. What is the meaning? Negative means temperature increases or decreases. That's why we are saying it is negative. In the case of semiconductors and insulators, it is negative. So they are asking which have a negative temperature coefficient. So here metal, no idea. Metal and semiconductor. No, wrong it is because metal included. Semiconductor itself. So right answer. So the right answer is option C, where the semiconductor itself has the alpha value negative. B is not correct because it includes metal. A already we know A is metal, alpha is positive, and here D is alpha for metal, alpha value is positive. So that we did question 9. Now we are doing the next question now correctly. So look, question now, which of the following graph represents variation of resistance of copper with temperature? I think those we explained last time. So based on that, the students can say, look, 2020 NEET question it is. Which of the following graph represents variation of resistance of copper with a temperature? We know in the case of copper, resistivity increases with the temperature. So we have the option actually for this. If I am considering now, this one is there, that is this picture now correctly, roti, this one may be there, and this one may be there correctly. But the point here, look, it is copper now correctly. Copper is a metal. In the case of metal, we know that I'm explaining. In the case of metals, alpha, if we are considering the alpha value, alpha is positive. Moreover, their resistivity is small. They have less resistivity. So accordingly, we are selecting option C, the right one here, because it's varying with the temperature, increasing with the temperature, and its value is also low. So the right option is option C coming. So that's a question. It's a direct question, textbook question, NCERT textbook. This graph is there, so you can refer all the three graphs. These three graphs are repeated many times. Now the next one, question 11th. Question 11th is 2020 CBSE question. Please look to this question now. Please see what's the question there. A car battery is charged by a 12-volt supply, and energy stored in it is 7.2 into 10 raised to 5. The charge passed through the battery is. So what are the datas given? Voltage given, that is 12. And we can say correctly. Now the next one, the charge here, energy given. So energy given, I'm marking now energy. So energy given 7.2 into 10 raised to 5 joule. The charge passed through the battery. So they are asking what is the charge passing through the battery. Oh dear, so some questions are asking this question now. C and D are same in the options. Then why it is like that? Okay, I'm going to that explanation. See, look here in this diagram when we are pasting, see it is correct. C and D will be there. But for option D, the graph is like this actually. This is the picture now. So I cannot select D. Why I cannot select D means it should have a low resistivity. So that is why we are selecting C here correctly. Okay, now I think you got the explanation. And now see, look here, voltage is 12, energy given, they are giving Q now. Can you say how we relate charge, voltage and energy? We have the formula, look, energy always in our examinations, energy is related to work. Work and energy are same unit. We have work energy theorem. Work and energy are equal. So we can find here correctly W is equal to QV is there. Formula we studied. So we can calculate the charge passed now. So Q is equal to W by V is coming. So what is W value? W is there 7.2 into 10 raised to 5 divided by 12 it is. So I can write 7.2 means 72 into 10 raised to 6 divided by 10 raised to 4. 72 into 10 raised to 4 divided by 12 is there. So 72 by 12 is 6. So the answer 6 into 10 raised to 4 coulomb. So the right answer is option A. Option A, the right answer is coming, where 6 into 10 raised to 4 coulomb is there. So this is the relation. Look, energy and work are equal. W equal to QV. Now see, we are trying now 2020 CBSE question. So what's the question there? A cell of internal resistance is small r connected across an external resistance capital R can supply maximum current when R equal to someone is asking about that, why we took that that is work and energy. Yes, Dhruv, it's right. Yeah, work done is energy. Work done is equal to energy. Work energy theorem. Right. Okay, now a cell of internal resistance small r connected across an external resistance capital R can supply maximum current when there is a theorem that we studied, maximum power transfer theorem. So look, it's a direct question from that, maximum power transfer theorem. What is maximum power transfer theorem? Power transfer will be maximum when internal resistance and external resistance are equal. So we can say when internal resistance and external resistance are equal, the power transferred will be maximum. So we can say here the right answer is option A, capital R is equal to small r is there. Yes, Pavitra, right? Okay, so capital R is equal to small r. That's the picture for the current maximum. Now we are trying question 13 now. Question 13 is 2022 CBSE question. So look, two sources of equal EMF are connected to an external resistance in series, capital R. The internal resistance of the two sources are R1 and R2, R2 greater than R1. If the potential difference across the source of internal resistance is R2 is 0, then what is the relation between them? So first of all, we can draw this diagram. Look, two cells, so we can say EMF, equal EMF, so E is there, are connected to an external resistance R in series. So series means there we are connecting minus to plus, okay, connected to an external resistance, the capital R in series. So this is our diagram. Now, when two cells are connected in series, what is the equivalent EMF? Everyone knows equivalent EMF is 2E. Series connection means minus to plus. So, adding EMF will be added up. So, E plus E will be equal to 2E. Then we have the current equation. So, what is the current equation? We have E equivalent divided by R plus R equivalent is there. As we have two cells here, so we can say 2E divided by R plus R equivalent, internal resistance equivalents. Two cells have internal resistance R1 and R2. So R1 plus R2 is there. So we got the current expression in the circuit now, that is 2E by R plus R1 plus R2. Look in the question what they are saying. If the potential difference across the source of internal resistance R2 is 0. Please everyone see. So what they are saying, potential difference across the second cell is 0. We know the formula, potential difference across a cell. We have the equation. So that is E minus IR. So I am writing E2 minus I. In this question, it's very clear. This internal resistance also represented by capital R. E minus I R2 is equal to 0 is there. E2 minus. But E2 is E. So I can write, that is correctly now, E minus, I value I am substituting, 2E by R plus R1 plus R2 into R2 is equal to 0 is there. So now simplification, mathematical simplification, take to that side. So E is equal to 2E R2 by R plus R1 plus R2 is there. So now look, E and E cancels. Now cross multiplications. So when cross multiplication, what we are getting now correctly, see look, we can say 2E is equal to, so you will see that correctly, the cross multiplication step here, this here 2R2 is equal to R plus R1 plus R2 is coming. So I can write here, so that is 2R2 is equal to, 2R2 is equal to R plus R1 plus R2 is there. So I need R. So I'm taking to this side. 2R2 minus R1 minus R2 is R. 2R2 minus R2, R2. So R2 minus R1 is R is there. So we have the formula R2 minus R1 is equal to R is there. So please see in this question now, the right answer is R equal to R2 minus R1 is there. Yeah, so actually it's an indirect question, but in the last, I like that comment actually. Yes, Maria Gold, I like that comment. But the point is that see, we have in our board examination we have questions. So last this 2022 we have two sections, section A and section B, like that. So some we like, some we don't like, but we have to do the hard questions also. It's right, it's good, funny. Now look, we are explaining the next question now, that is question 14. This is 2022 CBSE question. Kirchhoff's first law is given by sigma I equal to 0. Kirchhoff's second law is given by sigma IR equal to 0, where the symbols have their usual meanings are respectively based on. That's the question. So dear, this question is a direct question, but sometimes we may have a confusion. So please, to avoid confusion, theory areas we have to be sound, read as much as possible and write and practice. Yesterday I saw some students, they are looking to the notebook and studying. It will not feed in brain. Your head is connected to the mouse and that mouse is your hand. So write by hand and recall them correctly. So we can say Kirchhoff's first law, conservation of charge. And we can say Kirchhoff's second law, conservation of energy. So direct question, no need of explanation. So the right answer is option D is the right answer. Now question 15 we are explaining now correctly. Yes, right. Now look, an electric bulb is rated 220 volt. Okay, someone are saying, look, now look. See, look, an electric bulb is rated 220 volt and 100 watt. When it is operated on 110 volt, what will be the power consumed? See, even for this board examination, a most possible type of question it is. A very important question. Usually in my classroom I am saying a word, my students knows that correctly. We are saying imbo question it is. Very important question correctly. So look, what is that very important question? An electric bulb is rated 220 volt and 100 watt. So voltage is given 220 and power is given 100 watt. Then from this data what we can calculate? So we can calculate resistance, because power given and voltage given, so we can calculate resistance. R equal to V square by P coming. So we can say V square, that is 220 square divided by 100. 22 square 484. So 484 is the resistance. Okay, after getting resistance, I want to find the same bulb now. Look, the bulb is same. Now look, that bulb has resistance we calculated 484 ohm. That bulb is now connected to 110 volt battery. So it is now connected to 110 volt battery. So its resistance will be same. What is the resistance? 484 ohm. So what is the new power now? That is V square by R. The new voltage is 110. So 110 square divided by 484. 110, 11 square, that we can say that is equal to 121, then 00 divided by 484. This you can simplify. So denominator 4 will be there. 100 by 4 and that is equal to 25 watt. So the right answer that we are getting correctly, yes, 25 watt is the option A. The right one, 25 watt is the correct answer here. So please see, if power given and voltage given, we can find the resistance, okay, by using the formula V square by P. Same resistance that we are using in any circuit, because bulb is not changing. So the 100 by 4, 25 watt is there. This bulb has resistance 484. So you are connecting to any battery, resistance will be remains the same. So that is equal to 484 coming. So now the next question we are doing, question 16. So look, two resistors R1 and R2 of 4 ohm and 6 ohm are connected in parallel across the battery. The ratio of power dissipated in them, P1 is to P2, will be 2020 CBSE question that we are explaining now. Look, two resistors. So I'm saying one resistor 4 ohm and another resistance 6 ohm connected in parallel. You know, they are not connected in series, they are connected in parallel. So you know, are connected in parallel like this, and then connected to the battery. You know, see, the connected to the battery now. So they are saying what is the ratio of power dissipated. Parallel, voltage is same. Suppose it has a voltage V, it also have the voltage V. So power dissipated P1 equal to V square by R1, and we can say P2 is V square by R2. So I can take the ratio P1 by P2. So that is V square by R1 divided by V square by R2. So that is R2 by R1. Direct question. I wrote the detailed step to clear only. So R2 by R1, 6 by 4, and that is equal to 3 by 2. So the right answer is option B, that is 3:2 is the right answer is coming. So the right answer is 3:2, question 16. Now question 17. Question 17 is what we did before, same question, same idea. Please look, the element of a heater is rated PV. If it is connected across a source of voltage 2V, then the power consumed by it will be, look, it's power given, voltage given. So we can find the resistance. What is the formula? R equal to V square by P. This resistance will be same, no change will be there. So I can find the power consumed in the next case. So you know, the next case power P dash is equal to which voltage it is connected? 2V. So 2V all square divided by the resistance, V square by R. So we are taking now correctly. Yes, right. Okay, so now that is equal to 2V. So 2V means 4V square by R is there. Look, what is V square by R? That is P. So we can say 4P is the right answer. So we can say option D, the right answer is coming. That is equal to 4P is there correctly. So the question 17, right answer is 4P is there. Now we are trying question 18 now. 18, the question is 2022 NEET question. Please see, 2022 NEET question, very hot question. When I am touching that question, I feel the hot. Two resistors of resistance 100 and 200 ohm are connected in parallel in an electrical circuit. The ratio of thermal energy developed in 100 ohm to that in 200 ohm in a given time. So look, energy in a given time, so that is power. Read the question once more. The ratio of thermal energy developed in 100 ohm to that in 200 ohm in a given time. So energy by time. So that we can say that is power is there correctly. So we can say that it's clear, it's power coming. So power we want to calculate. You know, power is equal to V square by R. So we can say P1 is V square by R1 and P2 is V square by R2 is there. So we are simplifying that correctly now. So P1 by P2 is equal to, as before, we got the final result. R2 by R1 is there. So R2 is 200 and R1 is 100. So the ratio will be 2:1. So the right answer is option A, that is equal to 2:1. So I'm explaining once more. Please see, look there. Yes, right. 18A. Yes. Look, what's the point there I'm explaining? Look, two resistors of resistance 100 and 200 are connected in parallel. Thermal energy in a given time. So thermal energy means it's clear that is equal to energy in a given time. Energy by time. It means thermal energy per unit time. So that is equal to power. So power it is there. P1 by P2, R2 by R1 is there. So that is equal to 2 by 1. Now we are ready to do the next question. Look, question 19th. 2022 NEET. Please see. A copper wire of length 10 meter and radius 10 raised to minus 2 by pi meter has electrical resistance of 10 ohm. Okay, the current density in the wire for an electric field strength of 10 volt per meter is. So what are the datas given that I'm writing now? Look, its length given, that is equal to 10 meter. And we can say its radius given 10 raised to minus 2 by pi meter. Radius given. And then we can say its resistance given, capital R, that is 10 ohm. And the field strength, electric field strength is given, that is equal to 10 volt per meter. They are asking what is the current density, J we want to find. So if J and E are given, so we can say it is always coming like that. J and E are given means J equal to sigma E. That's a relation. So dear, sigma has no idea given here that we can check what are the datas given. You know, rho equal to RA by L. Okay, so we can say from this sigma is equal to L by RA is there. It's a reciprocal of resistivity. So I can write J is equal to LE divided by RA is there. LE by RA. So substituting the values. So L given, that is equal to 10. Electric field given, that is 10. And resistance given, that is also 10. But area we have to find. Area is pi r square, you know. So look, pi, then r value given here, 10 raised to minus 2 divided by pi, the whole square is there. So simplifying. So this 10 and 10 cancels. 1 pi square will be cancelled here, so that pi will come to the numerator. So we can say here 10 and this pi will be there in the numerator and divided by 10 raised to minus 4 is there. So taking to that to the numerator, so it's coming 10 raised to 5 pi is there. So the right answer is 10 raised to 5 pi is there. So it is option A coming correctly. 10 raised to 5 pi ampere per meter square is there. So that's the idea. Look, 10 and 10 cancels. 1 10 here, pi is there. Taking this minus 2 into 2, minus 4 to the numerator. So it's coming 10 raised to 4, 10 raised to 4 and this coming 10 raised to 5 pi is there correctly. Yeah, right. 10 raised to 5 pi. Neat question like that. Neat question, no. Not all questions. Some questions are little long. Okay. Now we are doing the last question today evening. So please, question 20. Wheatstone bridge there. So look, what is a Wheatstone bridge is used to determine the value of unknown resistance X by adjusting the variable resistance Y as shown in the figure. For the most precise measurement of X, the resistance P and Q will be there. So, you know one important point, it is a Wheatstone bridge. You know, we are lucky actually for board examination, meter bridge is not there, potentiometer is not there, but Wheatstone bridge is there. Wheatstone bridge is a very important area for the board examination. So, here in this case, we studied one important point for Wheatstone bridge. The bridge will be more sensitive, bridge will be highly sensitive if all the branches have equal resistance. All the branches have equal resistance, the bridge will be highly sensitive. So here look, we can say P and Q they are saying. So they should be, we can say they should be approximately equal and are small. So that's the right answer correctly. So the right answer is A. It should be approximately equal and are small is there. So these are the ideas correctly. Now look, so now what is 2x? 2x is not actually giving to confuse also, to confuse only. So all the options are not right here. Option A only right, should be very large and unequal, that is wrong. And we can say do not play any significant role, should be approximately equal to 2 times. Should be 2 times their meaning correctly. So it has no meaning there correctly. So you know only one should be approximately equal and small is there. So I think we covered 2022, 2021 all important questions we completed now correctly. Yes, could you explain this question once again? So I will explain. I didn't understand what the option D mean correctly. Okay, now see, now look here, the question I'm explaining, right, look, now see, look, in order to, in the case of a Wheatstone bridge, to have a high sensitivity or to increase sensitivity, all the branches should have equal resistance. So all the branches have equal resistance means P, X, Q and Y all should have equal resistance. Yes, we can say, so we can say correctly P and Q are equal resistance. Okay, look, P and Q have equal resistance, then X and Y should also have equal resistance, then only the bridge becomes more sensitive. Okay, thank you. Now, so we are winding up the sessions now. We'll meet another crack session, you see, for the examination correctly. Yes, right. Wheatstone bridge works upon equal resistance. If they are equal, it will be more sensitive. If they are equal. Yes, thank you all. Yes, thank you. If you have any doubts, you can contact and you can ask and make it clear. Thank you. Yes, right.